So what's the object moves at constant speed attached to a string, moves in a vertical circle. Let me get this next person in. Constant speed, vertical circle. What is the tension at the top? When you're at the top, you've got two. When you're at the top, you've got two forces pointing to the center. That's the tension, the string's tension, and the weight, both pointing to the center. And what are those two forces equal? Well, they're the centripetal force, which is mv squared over r. Subtract mg from both sides, and you find that the tension on the top is the least because some of the centripetal force is provided by the weight, so you don't need much of a tension to maintain a particular velocity. Hold on. So there you go. Whoops. So the tension is greatest at the bottom. Why? Let's take a look at the tension at the bottom. The tension points to the middle, so it makes it a positive force. Anything pointing to the middle is a positive force. The mg points at the bottom away from the center. It's a negative force. Add mg to both sides, and you get that the tension at the bottom is the greatest because the centripetal force has to exceed the weight. The tension at the bottom, or the string's tension must exceed the weight by whatever centripetal force you need. So you can see that now that the tension at the bottom is mv squared over r, the force that's causing the circular motion and turning the body, plus the mg. Tension is greatest at the bottom. Now, be careful about this one. There's a question that could trip you up. Why? You're going at constant speed in a circle with a constant radius, and you've got a constant mass. What do we know about centripetal force? The tension changes, but let's take a look at this equation. As long as the mass, velocity, and radius doesn't change, how could you say the centripetal force changes? Look at the equation. Any clarification needed on that one? The tension changes, but not the centripetal force if you're not changing m and v and r. All good? Everybody good? Okay. Oops, let me admit. So you're not changing M or V or R. So be careful with that one. I suspect some people might get tripped up. You've got a object going in a circle, vertical circle. I describe the forces at A. Well, at A, the mg and the tension point down. They're both positive. How about B? Once again, the tension would be towards the center, and the weight would be down. That's why the tension has to be so great at the bottom. What about the... Okay. What about the minimum speed? Well, you worry about speed at the top, obviously. If you were swinging a weight in a circle, vertical circle, you're really going to especially worry about it at the top. That's at the minimum speed. There's no tension at the top. So I take my typical equation. Did you see how this person crossed out the t-top? She said at the top, the tension will be 0. So the only thing providing the centripetal force at the minimum speed is the mg. Of course, the masses cancel out also. So you get g equals v squared over r. What's the velocity? Cross multiply and take the square root. Any questions on that one? Tension. Now, the tension is 0 at the top. What about if you're in a motorcycle going over a hill? If you go too fast, everybody knows what's going to happen. You're going to leave the road, obviously. So the question is for a motorcycle is not the minimum velocity like a rock on a string. It's the maximum velocity where you'll still maintain contact with the road. What happens when you exceed that maximum velocity? Your normal force equals 0, and the only centripetal force is your weight force. So normal on a hill, the normal force equals 0. How about if you're on a loop? Let's say a roller coaster on a loop. What is 0 at your minimum speed? The normal force again, the track's force on the roller coaster. It'll be near 0 if you go too slowly. There's never an issue of going too fast. Everybody knows that, unless the track is weak. But you're not going to fall off if you're going too fast. You fall off if you're going too slow. Okay. So number 2, satellites orbit in their different masses. That's why I called it M1, 2, 3, 4. Rank their velocities. Well, when you look at the equation, what equation would that be? Whenever you're asked a question about velocity, you're ranking the velocity. Pick an equation with velocity. Can you see that over here? mv squared over r, where the mass of the satellite cancels out the little mass, the orbiting mass, and you're left with V equals radical GME over R. Now, notice, let me just say this is sort of a generic equation. If the big planet happens to be the Earth, this is the equation. But what if it was a satellite going around the moon? Well, that wouldn't be ME, would be MM, or if it's Jupiter, the big planet being orbited is the thing that remains. The little satellite or that's what cancels out. So now let's look at this equation. V equals radical GM over R. So how do we rank this? Well, the first thing that we should do is say, don't be fooled. The mass plays no role. This equation tells me the mass of the satellite has no effect, only the radius of the orbital radius of the satellite. So now I look at these choices differently. I ignore the masses because they have no effect and only look at the radius. Since V is on the top and R is on the bottom, that's a kind of inverse relationship. It's inversely related to the square of R. So, but still, the bigger the R, the smaller the V. So what am I doing? Ranking it how? Oh, greatest velocity would be the small, she picked D because it's a half R. That's good. The smallest R. Then there were 2 ties. A and B are tied because they're both R, and the slowest one is 2R. If you know a little about planets, and some of you do, you know Mercury's the fastest. It's the closest to the sun. Um, Venus is the second fast. What's that? My very educated mother just showed us 9 planets or something like that. Neptune is very far, so it's the slowest of them all. And so there you go. That equation has V in it. We cross out the little m. Mass doesn't matter. And so you just look at the orbital radius, not the radius of the planet. Maybe somebody could type that in there. Maybe would you do that? If someone's on the, could you highlight that the R in this equation is not the radius of the planet, it's the orbital radius. Would somebody do that for me? So there's no confusion. It's not the radius of the planet. It's the orbital radius, the radius of the orbit around the large planet. Satellite's orbit. Maybe somebody will do that. This is a new question I ask. What if all of these satellites were taken to a larger body, but they maintain their same radius and their same mass? How would their orbital periods have greater, equal, or smaller? Well, let's look at the equation again. V equals radical GM over R. So someone did it. Terrific. So what's the relationship between the V and the M? Well, they're both on the top. So the larger planet, now it wouldn't be ME because it's just a different planet that's a larger body. We could call it MP if we'd like, and maybe somebody would do that, call it MP, mass of the planet. So if the M is larger, since it's in the top, the velocity at that given radius would also be larger. So let's see what it says. Yeah, the orbital periods now. I've been talking about velocity. What's the relationship between orbital period and velocity? Maybe somebody could type that in, that V equals 2 pi R over T. Is there anybody? Am I losing? Am I talking to you girls? I am, right?
Yeah.
Okay, good. Nobody wants to type in there for me? For us, rather? All right. Okay. Um, so maybe you could write it down if somebody doesn't want to type it. V equals 2 pi R over T. Why did I say that? Because first I'm going to say that looking at this equation, if the M is bigger, at that radius, the velocity would have to be bigger. Oh, thank you. So the velocity would have to be bigger. Yeah, actually, this stuff, could you write this? I'm sorry. Is that Eliana? Could you write it down at 2A? Because that's really what I'm talking. So just write it down here. Bring that down under 2A. I think right after the smaller, press enter. And then you could write V is 2 pi R over capital T. So right, see, we're talking about 2A right now, right here. Okay. So capital V is 2 pi r over, yeah, good. V equals 2 pi r over capital T. V is in Victor, 2 pi r over T. You can write, yeah, pi, that's good, over T. And so make that A of V, that's velocity. So what I'll do is I'll say, well, the V is going to get bigger because the M, if the M is bigger, if my new planet is bigger, my velocity gets bigger. And if my velocity gets bigger, my period has to get smaller. So the answer is, let's see, the mass of the body is bigger. The velocities would have to be bigger. Good. So the period, good. So the period, we have it already written. Terrific. If the velocity, that's a good explanation right there. Did that go too fast for anybody, or would you like me to explain? Was it too much? Okay, it's all good. Just feel free to jump in. All right, this is a bunch of problems that are very close to a problem like this. Planet has a radius of 1/4 of the Earth and a mass that's 1/5 of the Earth's mass. What about the gravitational acceleration g? So you take this original equation over here and cross out the m's, the little m, and you're still left with the mass of the Earth. So now you substitute the changes on the right. The top, the mass is 1/5. The bottom is 1/4 of the radius, but that gets squared. 1/5 divided by 1/4. Well, I'll have 1/5 over 1/16 because the 1/4 gets squared. Multiply top and bottom by 16 to clear that fraction in the bottom. And it's a change of 16 over 5. So what she did is she says, well, our acceleration is g. It's 10, or she used 9.8, which is fine. You could use 10, and she just multiplied RG by 16 over 5, and she got a new G. You, of course, can use 10. You know that. Any questions on that one? Any follow-ups? So you change on the top, change in the bottom, but when the ORs change, you square that change. So the top changes by 1/5, bottom by 1/16. Top do what your math teacher would tell you, clear the fractions by multiplying top and bottom by 16. So what we've got is the change if the right side changes by 16 over 5, well, then the left side must change by 16 over 5. And 16 over 5 times 10 is, or if you like, what this person did, I think is, you certainly can multiply by 9.8. All right, all good on that one? Okay, feel free to jump in. Number 5, an object on a string moving in vertical circle at a minimum speed. When the object reaches its peak, which force is 0? We talked about that at the minimum speed, the tension becomes 0, and the only centripetal force is the weight. So it's going slow enough where the weight actually can serve as a centripetal force. For a car moving over a hill at a maximum speed, if you exceed a certain speed, your normal force will be 0. And you're simply saying you're going to, actually, your normal force could be 0, and you're not really leaving the ground. You could technically stay on the ground. You're just feeling no pressure from the ground. You probably have experienced that being in a car, maybe going over a hill. You feel a little lighter in your seat. If you go fast enough, you'll technically be in a state of free fall. You'll feel no pressure from the seat at all. There is a speed that you could stay in the seat but feel no pressure from the seat. What is that speed? It's where the tension, the normal force equals 0, and mg is your only centripetal force. Would somebody move this 6 over to the next page? I only say that because I have no keyboard. Maybe I should attach my keyboard. I've got this pen in my hand and I'm not really using it. So I'm gonna do that. I'm gonna attach the keyboard. Thank you, Ellie. Who's that? Miss Coleman. Thank you so much. It's kind of like I'm doing 100 things, and it just helps when you can do that. All right, car moving at 1,000 meters. That's a radius of 1,000 meters. It's got a coefficient of static friction of 0.75. What's the largest speed the car can travel without skidding? Now, when you're going in a circle, what is your centripetal force? It's the rubber friction on the friction between the rubber and the asphalt, the friction is your centripetal force. It's your center directed force. And so we start out with this equation, mv squared over r. Why? Because they mention r, and its move is speed is the question. So I need an equation with actually speed in it. So mv squared over r is very good. Now your net force, your centripetal force is mu mg. Now wait a second, this is a mistake here. Let me fix this. Could you get out that could you get, you know what you do? Take out that m that's crossed out, Eliane. You see the don't make it mu. Oh, I know what she did. Oh, that's mu. You know what? Just take out the crossed out m and just make the U. We'll call the U that. Thank you. Just get rid of that guy right there. Oops, what did I just do? Hold on. Did I mess things up? Hold on. Yeah, great. Thank you. Now, we'll keep the M right over there. Why is it doing that? It's so weird. But now, oh, maybe my cursor was over here. Let me get my cursor over here. So this will keep the. I'm looking at your cursor. Let me get my cursor down over here. So it looks like that. Now this becomes the m's cancel out, so it's UG. That U is really that UG equals V squared over R, and then what we have to do is solve for, so the V becomes radical. I don't know if any of you know how to do radicals, but I'll just do it this way. Cross multiply GR square root raised to the 1/2 power. I know some of you are pretty good. I think I just have to do this. Format, little superscript. Maybe somebody could do better. No, not that's any big deal. So I did. Wait, did I do that right? Oh, V equals radical. Yeah, GR. Yeah, that's good. I think no, I left out the mu. Let's see. You multiply this is I know I did it wrong. I think the mu has to stay there. Yeah, good. Mu GR. So double check that actually we actually have the right answer. Let me look it over. This to multiply both sides by r. Good. Take the square. Good. Could you everybody double check that? Does 0.75 times 10 times 10,000, does it actually come out to 194, girls? Would you double check that so we all know we have the correct info? So 0.75 times 10 times 10,000. All good, Kim?
No, that was actually the wrong one. Hold on, give me 1 second.
You'll get that. Could you fix that then? Girls, what are you getting when you do mu times g times 10,000? So it comes out to 274. Anybody corroborate that answer? Oops. Oh, that.
I got that too.
All right, terrific. Good. Let me put that. Getting that? So there you go, girls. You follow that? So when you're going in a circle in a car or on a bicycle or running, your centripetal force is provided by the friction. And well, you can only go so fast before you lose. This velocity is actually the maximum velocity you could go. You could go obviously under that velocity, but you can't go over that velocity because right now you're right at at maximum coefficient. Yeah, thank you, V max, right. Nobody worries about running a circle too slowly. We know the friction is going to be good. The issue is at some point your speed is too great for the friction to handle it. So the limit situation is too fast. Good. Did I lose anybody?
Is there not supposed to be a 1/2 on that?
That's
Like,
a radical. That's to the. Oh, someone just put their. Okay, let me fix it. Someone put. How do you do the radical, by the way? How do you do that? Anybody? It's like an insert. Yeah, thanks for catching that. I just hadn't. The radical wasn't there, so now it is. So does that look? Is that okay? But with you girls, that looks. looks good enough to be a radical? Is that okay? Do you get that that's radical UGR? If you do, hopefully you do. Can I leave this now? So an object with a mass of m moves in a circle radius r. If the
Just
centripetal
on the
force,
geometry.
yeah.
Sorry, what do you mean by like when it is too fast for like friction to handle?
Well, you know, when are you in trouble if you're running in a circle or driving a car in a circle? You're never in trouble. You never worry about not having enough friction if you're going very slowly. You can, but when do you put your friction to the test is when you're going too fast. We just solved for 274. If you're going at 1 meters per second in a car, you at this with this nice large coefficient, you're never going to slip. This question is about skidding or slipping. You know what I mean? So your car at this, if as long as you're under that speed, your car will never skid or lose its traction. You get that? So when
Okay,
you're going,
thank you.
you go in a circle. Nobody worries about like you're running in a circle. When would you have a chance of slipping if you're going really, really fast? You know, especially if it's a little muddy. But if you're going slowly, if you're walking in a circle, nobody worries about slipping. An object with a mass of m moves in a circle r. Centripetal force is F. What would the centripetal force be if the speed increased? Now, why did she use this one? Well, she found an equation with speed in it. And what else? The other thing that they mentioned, centripetal force. And so what she did is she plugged in the changes. The speed is changed by 5. So she plugs the change in because all she cares about is the change. The v changes by 5 squared. The radius changes by 3. 25 over 3 is 8.33. So the answer would be, what's the new centripetal force? It's 8.33. Oops, 8.33 F. So it's no longer F because of those changes. It's 8.33 F. Because what if the right side changes by 8.33? The law of equality says the left side has to change by 8.33. That's how you do it. What are the changes on the right? I'll sum up the changes on the right. Well, the right changes by that much, and this is an equality, well, the left changes by that much, and that's my answer. It's now no longer F, but 8.33 F. Jar of spaghetti, 2 newtons. This is a trick question. What is the mass on the moon where the acceleration is 1/6 g? Well, let's find the mass of the spaghetti here on Earth by dividing by 10. She says the mass of the spaghetti in the moon will be 0.2 kg, same mass that it was on the Earth because mass doesn't change, in any place in the universe. Okay. Here's a question. Any questions on that one? So you've got a person who weighs 400 newtons. What would her weight be? What do we use for weight? Well, I don't think I would use, hold on. Oh, what is it? Would her weight be whose mass plus mass? Well, hold on. What did she do here? I think what you do this, I would do it this way, FG. Why? Because weight is a force of gravity. So I would do it this way. I'm not sure that, yeah, I think that, I'm not sure she didn't still get the right answer, but could someone take the cross through the slash through that, take that out? So she still did it right. Whoever did this did it right. I think, let's check it out. The mass of this planet whose mass is twice that of the Earth, good, 2 on the top, I change it 2 on the top, and 6 times the radius, 6 gets squared, 2 over 36, which is 1/8. Yeah, the answer is still correct. If her weight is 400 newtons, it's going to be 1/8. Remember, 1/8, and let me fix this as well. The right size changes by 1/18th. The left side changes by 1/18th. She's going to be, this person or whoever is a person, yeah, person's going to be 1/18th of their weight, and there it is. So she used G, she got it right, but really she should use FG because that's That's what's close to weight. Your weight is the force of gravity on you. Okay. Any
Mr. Mitch
follow-up?
Gregory,
Yeah.
how do you know like when to use FG versus MG since like they come out to the same?
Well, you know, it wouldn't be wrong to use it, but I think you get yourself in less trouble. Uh, yeah, this worked, you know, MG, but you crossed out the M's. And so you're really finding the changes in the G. Now, you certainly can find it. You could say, well, I found the change in G. Well, if G changes by that much, then my weight will change that by that much. It's not incorrect thinking. But if I'm asking about if I'm doing a problem, how the acceleration due to gravity is changing, then I might work with mg, cross out the m's, find a change in little g, and then solve my problem. But the whoever did this, you know, it's another way to do it. It's not the wrong way to do it.
Okay, so
But,
if it specifically says weight, then use FG.
right, you can, maybe somebody writes that down. Maybe we'll put that over here. Maybe we'll put it right here. If you have weight problems, use g. If you have acceleration due to gravity problems, use that, derive that little g. If the distance between the Earth and a satellite is reduced to 1/6 of the original, what equation will I use this? Well, I'll just use this equation over here. Copy paste it over here. I mean, this is what they're talking about. So if the distance is 1, so the top doesn't change. Let me just do this. You do something like this. Well, the top doesn't change, so it's a 1. The bottom changes by 1/16, but that gets squared. So you're getting, whoops, you're getting closer. That's going to increase I'm going to expect an increase in the force of gravity. That gets squared. And so what is essentially 1 over 1/36. Clear the fraction on the bottom by multiplying top and bottom by 36. And right, the force of gravity increases 36 times. Okay. Would anybody like to look at the Google Classroom or anything else?
I have a question on the car example.
Okay. Here's the car, yeah.
So you said that the friction is the centripetal force.
Yeah.
So does that mean it's pointing down if you were to draw it out?
Well, is it pointing in a car? It's pointing. If you're in a flat ground, which we assume this is flat ground, the centripetal force is always points towards the center. So if you're running in a circle, where's the friction of your sneakers on the ground? Pointing towards the center. If you're in a car, where's the centripetal force that friction acting between, that exists between the road and the rubber? It's acted towards the center. Everything going in a circle must have a force that points to the center, and friction points to the center. Did I answer your question, or is there another question?
Yeah, thank you.
Okay, yeah. So there's a friction question. I stuck that into last minute because you got to have a centripetal force friction question. So I put one
So
of
the
those.
friction for this one is the centripetal force?
Yeah. Well, anything, like I said, a car going in a circle, you going in a circle, whatever going in a circle, friction is your centripetal force. You can't run. You're well aware you couldn't run in a circle without friction. It's what's providing you centripetal force. If you're on your bicycle going a circle, it's the friction that's acting as your centripetal force. Nothing can go in a circle without a centripetal force. And bicycle, runner, car, all use friction that allows them to move in a circle. Is there anything else? I could go to the Google Classroom, or I could do whatever you want me to do. Isabel?
At the bottom of the tip sheet, it mentions going over the multiple choice questions. Can you just go over a few of those that you
Yeah,
think?
I really, I would, you'd be very wise to really look at these. I think extremely wise to look at, not that they're exact questions, but they're very similar to a lot of this change stuff. Get to know your changes. Is there anything in particular that you'd like me to look at? Is there something maybe
Could you go over the question where it asks for like the planet X's mass and like planet Y's mass? I think it's number 6, and there was
Okay.
another one with it that was like the opposite. And
Okay,
it had
so
answers like 0.7 and like 1.4.
what's the answer to this one anyway? Anybody the answer handy?
I think it's C.
1.41.
Thank you. Which is radical too. So okay. In the old days when I first started teaching APB, one of the things the kids would be asked to do is memorize the square root of 2 and the square root of 3. So anyway, you don't have to do that anymore because you in the old days you weren't allowed a calculator. 2 planets have the same surface gravity, but planet B has twice the mass of planet A. Okay, let's see. How do you do a problem like this? Just general procedure is to, if you're very wise to, if there's a lot going on, to do this. Take a little, we've got A and A. Planet A is twice the mass. So A is M, and B is 2M, right? Right. I say planet A is twice. Okay. Same same G. So this has a G, and this has a. I wouldn't do it like this. I'd do it like as a table, but I'm limited here with what I got to work with the keyboard. So A and B. If planet A has a mass of R, I think I'm going to have to go with. I got to go with my pen and open up something that I could. So let me do this because I can't handle this. Let me just do this. I got to work with this. All right, I need your help then because I'm not looking at this questions. So I've got A and B. I think that B is 2M. This is M. They both have the same G. And what are we asked to do? What are we comparing with about them? They're R's, is that what? Oh, let me look over here. Planet A has a radius of R. What's planet B? So how do you do something to this? So the R of B, we do not know. Okay, so what is an equation that I'd use for little g, M and R? What comes to mind for you? I know what comes to mind for me, that this equation here has everything that I need, doesn't it? That the weight is equal to mg, but the weight also equals g m1 m2 of r squared. What gets canceled out is this. So now what gets left, m of the planet gets left, right? So we have 2 different planets. So let's now, what's equal? Well, let's clean this up a little bit. G equals gm over r squared. So we're told that both planets have the same g. So it's equally true to say, well, if they have the same g, that this is true as well, right? Now let's start to put our numbers in for A. Is now everything that doesn't change, just goes out. So we have M. A is just M, and its R is just R. Now B, its M is 2M, and its R, well, RB, I don't know what it is, but I could do that. What's nice is this becomes 1. That becomes 1. So now I have to cross multiply 2r squared equals RB squared. And what do I do to find RB? Take the square root of both sides. Radical 2r equals RB, which is radical 2 is 1.41. Square root of 2 is 1.41. See that? So just to go over it again, I made my table. It's really smart to do. I just wrote down what they told me, and I didn't know RB, so I didn't call it. I just called it RB because I didn't know it. I used the equation that has all those things that mg and r perfect fit. Mg equals g m1 m2 of r squared. The little m's cancel out, but the big M, the planet, always remains. This is what I get. And then I just get rid of things. I've said, well, they have the same G because they told me they had the same G. So I said Gm over r squared equals Gm over r squared, cross out the big G because it's a constant. So same thing on both sides. So then I go to here and I start substituting into the what they gave me. They said this is M, this is just R, this is 2M, so I plugged it in. This is RB because I didn't know what it was. Cross multiply, and I took the square root. Good question. I don't know that there's anything that hard though.
Thank you.
That's valid. You're welcome. Anything else on this? Let me clean this up.
You said that the super hard ones won't be on it. Which ones count as the super hard ones?
Which ones are the ones that take like 5 lines to finish? They just go on and on. Things that are really super multi-step ones, you know. I don't know if I had the time to scour. I don't have the. You have it in front of you. If it takes like 4 lines to do, I would consider that a super hard one.
Okay, thank you.
Yeah. Any other? Someone raised a hand. Let me see. Kira Brown.
Yeah, can you do 15, please?
Yeah. Okay. And wait a second. I want to get rid of that answer. Let me get rid of that. I don't want to. Did you read 15 to me? I would consider that a super hard one. Do you still want to do it? I'll do it.
Yeah, can you do it, please?
Sure. Okay, no problem. Okay, 2 moons. Here's another one where I'm making a table, and let me just clear this mess, and you're gonna read it somewhat slowly so I can get all this. Give me a second here. Let me just get rid of all this stuff. And so tell me, Kira, you have 2 moons, is that it? Or what is it?
Yeah.
Then they go ahead, read it to me. Is it moon A and B?
Yeah.
Okay. What do you know about A and B?
Moon A has a radius of r, and Moon B has an orbital radius of 4r.
So R and 4R. Okay,
Then
good.
the period of Moon A is 20 days, and then it asks how long it takes for Moon B's period to complete an orbit.
Okay, so if they're mentioning period, here's what I'm thinking. I'm thinking this, but then you know what? I'm also thinking that's not enough. You know, it's just not enough. I have to keep going on. I've got to derive the V equation. How do I do that? Starting here. The centripetal force when a satellite goes in orbit is this. Let's clean this up. The small satellite goes out. This becomes 1. This becomes 1. And V is radical Gm over R. Now, so what I do is, let's see. The first thing I'm going to do, I think, is, so I have to find the period. So I can see what happens to the velocity. Well, let's clean this up, and things that don't change become a 1. So it really is radical M over R. Do they have the same mass, these objects?
Yeah.
Okay, so that doesn't change. So V is proportional to 1 over R. So this R is, let's find out. So substituting the R, this becomes 1 over radical 4 is just 2. This is changed by 2. This is halved as well. What did they say the answer was for the period?
160 days.
Okay, then something I'm doing wrong. Let's see. 160 days. I remember. That's 8. Okay, read it again. Maybe I didn't hear it right. Read the problem again.
2 moons orbit a planet in nearly circular orbits. Moon A has an orbital radius of r, and Moon B has an orbital radius of 4r. Moon A takes 20 days to complete one orbit. How long does it take Moon B to complete an orbit?
Huh. Okay, let's see. It's very strange. But let's see what I did. Yeah.
Sorry,
Right.
where did you get the 1/2 from?
Yeah, well, this is obviously wrong because I'm not getting the correct solution. Let me see what's going on here. What mistake did I make? V equals radical. I remember solving this, but now what is period?
I think you have to set both of the V equations to each other. The 2 pi r over t and the radical gm over r.
Yeah, but see, what I was so puzzled by is I thought I could find the change in V, and then I would go up here and find the change of T. That's so puzzling. I remember solving this. Very interesting. It's a 4R, right? Because if you change this by 4, this is halved, and the velocity is halved, so the period should be double. I'll just have to pull up my answer key because there's obviously something I'm doing wrong. Let me see.
Where did the G go in the one?
Well, because the G is a constant, I just removed it. Anything that doesn't change becomes a 1.
So nothing in the other equation that the arrow's pointing to is constant? Like you can't take anything constant out of that either?
Well, I could actually, I'd say the M is constant, so I took that out of there. That's why I made it 1 over R. Huh. Let me see. So the answer is 160? Let's see. Periods, velocities. I'll have to pull up the solutions. That's all. That's so interesting. Let me take a second look. When the R's cancels out, so it's 4 times the R. It should be 1/2 the V. Well, that's interesting. All right, well, let's pull up the solution. Must be something, obviously, something I'm not saying. No problem. We'll pull up the solution, which is right here. And what number was that?
15.
Let's see what I did wrong. Okay. So let's look at the solution. Right, the R's cancel out. 2 moons nearly circular. A has a radius R, Moon B has an orbital radius R. How long? Okay. There's V equals radical GM over R. Okay. Oh, I know what happened. Yeah, I think this is what Julie was saying. I totally got it. Okay. Sorry, but I think Julie was actually saying this. Got it. Okay. Got it. Right, Julie? She was right. I had to period. Okay, let's clean this up. So, totally got it. Goodbye. Is this what you were saying, Julia? I think Julie was correctly saying, well, V does equal, you girls know how I got this, right? When I cleaned up that equation, then she says, well, 2 pi R over T is also V, and that equals radical GM over R. And so what doesn't change in this? Well, the 2 pi doesn't change. And the R does, and the period changes. I can call anything that doesn't change 1. That's R. The G doesn't change, so I can get rid of that. And the M doesn't change as well. Okay, it's all good now. Okay, so far so good. Did you know what I did there? I don't want to go any further until everybody's good. You all good? Where did I go?
For like the T under A, what does it say?
Let me get back to this. So the T
What
under
does
the,
it say?
where's the T?
Like
So
T
this is
equals 2 something.
2 pi r over T.
No, like it says A, then there's R, and then T equals, and I can't read what it says.
So this is 20 days.
Oh, okay.
We're just giving that 20 days. Sorry for being sloppy. Yeah, so what did I do? I have to get, I start here, but I've got to get everything in terms of what I'm interested in, which is R and T. That's why I had to replace the V with 2 pi r over T. And then to further clean it up, things that don't change just go away. The 2 pi doesn't change. The G and the M, nobody mentioned any change of G or M. Well, G is a constant, it wouldn't change. And now R over T equals, well, radical 1 is just 1. Radical R is just radical R. And so I cross multiply the T because I want to separate the things I want to compare. Oops. And so now I've got the two things that I'm comparing on either side. R is changed by, now I plug the changes in. 4 times radical 4 is 8. And so the new period is not 20 days, it's 8 times 20, and it's 160. No, there's nothing like that on the test, but it's a beautiful question. Okay. This is what Julia was in fact saying. She says, you got to take the 2 pi r and make it equal to the radical gm over r, because you got to make everything about r and t. How about, it's at 8:15. I'll do one more if you'd like.
Will there be anything like 27 on the test?
Let's take a look. '27. The same planet, same height. And what is the answer to 27?
I think it was A.
Yeah, it's V. You know what? There definitely is something like that. And where does that come from? Well, it comes from, you could write this down as I speak. There's something very much like that, that if you're comparing the velocity, it's mv squared over r equals g m1 m2 over r squared. What gets canceled out on both sides is the m. So the only thing that matters in orbital velocity is r. It's something we talked about before. It's like 28, isn't it? Remember we talked about in the tip sheet that the only thing that determines orbital velocity is r. That's why, you know, Mercury is the closest planet. It's got the smaller orbital radius. So that's what determines its speed. If two satellites have the same orbital radius, same height, orbital radius, they have the same V. This is something very, you know, you really need to know that one. Yep. And you need to know, you know, that's a key, that's a really key concept, sort of more important concepts.
Are we going to have partial credit for showing the work, or
yeah,
just
for sure. I'm going to give you partial credit, and I'll make that announcement. All the equations are in the top, but if you start out with the right equation, I would definitely give you some nice partial credit. Okay, so if you just start with the right, you know, pick the right one on the top and put it in there. Okay.
Okay, thank you.
You're welcome. We all done here, girls?
Oh wait.
Go ahead. One more question. What's that?
Like the weight force is Fg, but
yeah,
what is F sub g? Is that the force of gravity?
Well, force of gravity is weight. F sub g is weight. Yeah.
That's what I thought. And then
little g is the acceleration due to gravity, or what they call sometimes surface gravity.
Okay.
You know, our surface gravity is 9.8.
Are we using 9.8 on the test or 10?
No, 10.
Okay.
10.
Sorry, I just had a question about the AP questions.
Yeah.
So you said that like the scores would be released, but
Yeah, they're not released. You know what I think? I said it to be released after it's graded, but I guess it would require me to grade it. So I guess when I get off here, I'll just grade. I've never done this before. I've only done multiple choice. So I'll have to. It's not releasing them, so I'll what I'll do is when I'm done is I'll just hit the button. This is graded because there's some free response. I guess I probably have to take action on that. I'll try to get it to be released. All right. I'll try to get to.
Thank you.
All right, girls. Good luck. See you tomorrow.
Well, we need to know.
I'm gonna